Now we are ready to learn oxoacids. So these are the acids that we said that they contain oxygen, not directly hydrogen and oxygen, because we said if hydrogen directly connects with oxygen, it's going to form water, H2O, and that's not an acid. But then also acids are these acids that contain aside the hydrogen, they have the non-metal and oxygen containing that anion. So basically, it's an also anion that has hydrogen as its metal component. Basically that. So here we are going to see how to name those ones. So the prerequisite to naming this also acid depends on you knowing how to name anions. So because we've taken time to name anions like binary anions, right? So that's the prerequisite to this one. So we are going to see how that is used in naming the also acid. How to name the also acid is different from how to name the binary acid that we did in the previous session. So in this session, let's see how to just name them. We have some common ones here, common examples here that we meet mostly, and then let's see how to name them. So the first thing to do in naming this one is try to get the anion part. Get the anion part and name the anion part. Just get the anion part and name the anion part. So for example, if you have H2SO4, so our first one is going to be H2SO4. So H2SO4. So this one is basically containing hydrogen, right? Plus, and then the H, so SO4, 2 minus. So this 2 is coming from this side. So hydrogen usually takes, the frequency of the hydrogen is usually the charge on the anion. The frequency of the hydrogen in the species is actually the charge on the anion. Here, so the frequency is 2, right? So the anion will have an SO4 2 minus. That's what we have the anion. So just get the anion component of the acid, also acid, and then name the anion as if you are naming normal anion. Okay. So for the first one, you have SO4 2 minus. So SO4 2 minus is the anion part. So now we've learned how to name anions, binary anion like this one, and this particular one we named it before, and we said it's going to be tetra oxo sulfate into bracket 6, right? Now we are actually normally supposed to add ion here. Tetra oxo sulfate 6 ion, but we are not naming binary anion, the anion. So what we have to, the only thing you have to do is to replace this ion that you add at the end with acid, and you are done. So H2SO4 is actually named like this. This is H2SO4. So you take the anion part, name the anion as if you are naming the anion, and instead of adding ion at the end, just replace it with acid. So you have tetraoxosulfate 6 acid. That's the name for this oxo acid. So again, the prerequisite for this is to watch how to name binary anion. We have it in one of our videos. So check through the playlist. You see how to name binary anion, right? So basically, name the binary side, name the anion side, and add acid at the end instead of adding ion. Basically, that's the game. It's very simple. So yeah, let's see how to name the added. So basically, you have to get the anion part. So how do you fetch the anion part? So let's go to the next example, which is HNO3. So HNO3, the anion part is being the frequency of the hydrogen is 1. So it's going to be NO3 minus, right? So if you want to find this, it's going to be tri oxo nitrate 5. I should have added ion, but because I'm naming an acid, I will just say acid. Tri-oxo nitrate 5 acid. This is the name for the HNO3. HNO3. So tri-oxo nitrate 5 acid. That's it. So take the anion part again and then just name it as it's supposed to be. Let's look at the other one. So let me take the H3PO4 to tell you how to actually basically name. So H3PO4. So H3PO4. So we have named this one, right? It's H3PO4. For H3PO4, we are basically going to the anion part, and the anion part will be PO4 3 minus. But then, how do we name this one? Let me just take this time to calculate this one for you. It's going to be phosphorus is 1, right? So 1 times X plus 4 times -2 of the oxygen is equal to -3. So this one we have seen how we have calculated, or we have taken time to do that in that video that I mentioned to you. So x will be basically equal to, that will be 8 minus 3, that will be 5. So it will be something like +5, right? So that's how to calculate the oxidation of the phosphorus. So now we name the anion part. So the anion part will basically be tetra, because there are 4 oxygen, so it's tetra, 4 for tetra oxo. So 4 oxygen, that's the one here, tetra oxo phosphate 5, because that's what we calculated. Instead of adding ion, we are going to say acid. Tetraoxophosphate 6 acid. This is the name of this, tetraoxophosphate phosphate 5 acid. That's the name for this. So we know how to name this one. So you can try your hands on the other ones. So let me try and name this 2 and leave this remaining one for you to try. Then these are common acids that you'll be meeting in most of your, like, throughout the syllabus. So get familiar with naming them. Sometimes just name these things and get familiar with it. When you see them, you know that okay, that's just basically the name. So the next one is H2CO3. H2CO3. So if you calculate this, it's basically going to be CO3 2 minus, right? So I'm going to have triazocarbonate 4 acid. Triazocarbonate 4 acid, right? Basically, that's what we have. So instead of saying triazocarbonate 4 ion, that's the name of the ion. But remove the ion and just add acid over there, and we are done naming the Oxo-acid. It's very quick and simple. So we are done naming this one. This is the last one I'm doing for you. So the remaining 3 is for you to try, right? Try them and see, to solidify your own understanding of the concept. So this one, the anion part will be ClO3 minus. Why minus? Because the hydrogen here is 1, so ClO3 minus. So now let's name it. So it's going to try also chlorate. This chlorine, right? That also chlorate. That will be 6 minus 1, that will be 5. 5. So that was a chlorate 5 acid. That was a chlorate 5 acid. So this is the name of our Oxo-acid HClO3. We have HClO4, something that you can try. You have HBrO3 and then H2CrO4. Remember, all these ones are hydrogen containing substances that are aqueous form. That's what we said at the start for acids. It needs to be acid, it needs to be aqueous before you can classify it as an acid. If it is not aqueous, then you have to name it as a normal hydrogen to metal to anion combination that we talk about. So yeah, this is how to name also acids, and then this is leading us to the end of the first part of IUPAC nomenclature, right? So we talk about, so these are the very fundamental ones you need before we start tackling the subjects. That's why we are taking this one as an introduction component of the syllabus. So yeah, so I believe that by the time you are done with this playlist under this IUPAC nomenclature of inorganic chemistry, we should be able to start with inorganic parts of our chemistry. When we are getting closer to the organic part, we'll also take time to do IUPAC nomenclature of organic compounds. Then we'll name them, then we enter organic stuff, and then talk about that one as well. Let's start the journey. Let's see what happens in the next playlist, in the next video.